I learned from this interview that sleep is an incredibly productive process for our health and well being. It's not just resting and waiting to be active again. There's so much going on while we sleep, and there's so many moving parts and interacting processes, and it can be hard to get everything in sync, actually. But that's okay, because we're actually pretty flexible sleepers, and sleep is so important that your body will find a way to get it done. If you would, just go ahead and introduce yourself and talk a little bit about your background and expertise.
Hi, I'm Dr. Michael Grandner. I'm a clinical psychologist by training. I'm board certified in behavioral sleep medicine. I'm the director of the Sleep and Health Research Program at the University of Arizona and the Behavioral Sleep and Circadian Medicine Clinic at the Banner University Medical Center in Tucson, Arizona.
So we're talking about sleep, and
Yep.
my understanding is basically everything with the brain sleeps. So there's some universal functionality to that,
Some
and
some things
that's what I
without brain sleep. Yeah, I
yeah.
mean, it seems like evolution figured out a long time ago that when life is a sprint, it's short. So it figured out how to pace to enhance survival, and sleep seems to be a big part of that.
So yeah, so that's what I want to do first is kind of just go over some of the general function of sleep, what we understand, because it's this universal
Sure.
function that we all do. And then, but then at the same time, I feel like at least as humans, sleep is quite a personal thing in that, I
Yeah,
mean, people engage with it in so many different ways. So I want to spend the second part going over some of the quirks and see if we can kind of tease out what's good, what's bad, what's just personal taste, all that kind of stuff.
sounds
Kind of
good.
get. All right. So let's just start with basic physiological what happens when we're sleeping. I understand this is like mostly a brain thing first.
Sure. I mean, so if you're going to come up with a working definition of sleep, really what you have is it is driven by the brain, and most of our understanding of sleep, or almost all of our understanding of sleep, happens to be sort of around the brain and what the brain is doing. So a good working definition of sleep involves a few things, and then you can extrapolate those things to different functions. So one is you have reduced or absent consciousness. You're not always completely unconscious. There is sometimes some consciousness going on, but you're not. You also have relative perceptual disengagement, and that involves both the brain and the body. In that, your senses still work. You can still touch, taste, see, hear, smell, all of that. You can do that in your sleep, and you do all night. It's just your sensory apparatuses are still working. It's just they're disengaged. There's a gate, and there's a guard at the gate that says, "Hey, hey, hey, someone's sleeping. I'm not going to let you information in. I'm going to hold you out unless it's really important." And a good way to observe that is to go up to a sleeping person and, whisper a random word in their ear like popcorn, and they're not going to wake up. But at the same tone, same volume, whisper their name, all of a sudden they're awake. And that's because their ears worked just fine. They were still hearing just fine. It's just that the sensory gating said, you are not important enough to be let in right now. Okay, you can come in. You can come in. And this depends on the stage of sleep, and some people are lighter sleepers than others, and all kinds of stuff is going on here. But there's this relative perceptual disengagement throughout the body and in the brain. There's also lack of motor movement. You're not perfectly still. The amount of movement you have in your skeletal muscles changes across the night and across different sleep stages. So some stages you're kind of in a resting state. Some of them your muscles are much more resting. It takes more effort to be able to get them to move. And then you have REM sleep where you're actually actively paralyzed, where you can't move, even if you want to. And that's why sometimes you'll get twitches where you break through the paralysis, but you're actually actively paralyzed. It's actually more restful physically in that way than even the deepest of deep sleep. And so you have relative immobility, you have decreased or absent consciousness, you have perceptual disengagement. You're usually laying down. Different species have different ways that they sleep. Humans tend to sleep laying down. Um, another important element of sleep is that, again, this involves both the brain and the body in that it's naturally recurring and rhythmic. There's no other state of unconsciousness that's naturally recurring and rhythmic. You can't look at a clock and figure out how soon from now you're going to become delirious, or when you're going to enter a coma or exit one. But you can do that for sleep. And another key element that involves both the brain and the body is that it's reversible. You can't go up to a coma and go like this, and then all of a sudden they're not in a coma again, and within 5 seconds they're perfectly aware of their environment. It doesn't work like that for any other state of unconsciousness, but it does for sleep. And there's really important reasons for survival that we can do this. And it applies to the brain as well as the body in terms of being able to trigger this reversibility. And that reversibility is, in some ways, really the beauty of sleep. And some amazing things about how sleep works is captured by that reversibility, and just the engineering in there and the
Mhm.
machinery underlying that is fascinating. But that's also where a lot of problems occur because sometimes it's a little too reversible, and then people have a hard time getting back to sleep after they wake up, for example. So, in terms of what sleep is and how it's experienced, that definition does cross both the brain and the body. And then what's happening in those different states also can be similar to or very different from what's happening when you're awake, depending on the stage of sleep and where you are in your 24-hour circadian rhythm, which is in the background of all this because the sleep wake system and the circadian system are completely separate systems. They tend to coincide, and they work together, but they're independent. Like you can have a day night, you can be sleeping during your biological day and get regular sleep and be tired and have sleep pressure to have hunger for sleep, fall asleep, get sleep, wake up. That happens to be a time in your biological night. That's possible. Shift workers do it all the time. It's not really great. We were built to not be that way, but they are different systems. And so a lot of times they can disrupt each other. So things that have circadian rhythms that are more during the day or more at night also often means while you're sleeping. And so sometimes being in the biological night and asleep helps optimize versus being in the biological day and awake helps optimize, even though they are separate systems.
We'll take it from there then. Some of the signals that go into understanding those different processes that you were talking about, because it's basically, as I understand, just regulated by hormones, and your hormones tell you your body's to do all kinds of different stuff at different times, and it's
Yeah.
all just signals that your body's reacting to. So let's talk about some of those signals it gets and how your body just like understands what it's supposed to do and when.
Right. So the sleep wake system, separate from the circadian system, there's actually two different systems in the brain. There's a sleep system and a wake system that are separate from each other. So where the sleep system puts you to sleep, the wake system keeps you awake. Now, they sometimes go like this, but they can go independent of each other. So the sleep system is mostly driven by the neurotransmitter GABA, which stands for gamma aminobutyric acid. So it's a general, it's the same neurotransmitter that the way alcohol makes you tired and
Mhm.
Valium makes you sleepy and Xanax calms you down. It's that same neurotransmitter system. The same way that's how Ambien works. That's how sleeping pills in general work, almost usually on the GABA system. When GABA is elevated, it suppresses things. One thing it does promote, though, is sleep. But you also have a wake system that involves a lot of different neurotransmitters like serotonin, norepinephrine, and a few other, and dopamine that are involved in waking you up. And so a lot of people, for example, when they take a sleeping pill, sometimes it makes them really sleepy because it boosts their sleep system. Sometimes it doesn't work because their problem wasn't that they needed a boost to their sleep system. It's just that their wake system was too high, for example. So they work in context with each other. And then there's another system in the brain called orexin, which is a neurotransmitter that most people haven't heard of. They've heard of dopamine and serotonin, but they haven't really heard of orexin. One of the things that orexin does is it stabilizes wakefulness. And that's what makes it so that when you're awake, you kind of stay awake until you're asleep. And that's one of the things that orexin does. And so you have this interplay between these different systems that wake you up when you want to be awake, keep you awake even though your sleep pressure builds across the day, like hunger. And then when it reaches a peak and it gets high enough, you can fall asleep. And then you transfer into sleep. The switch flips to sleep, and then you stay asleep until you wake up. Though unlike wakefulness, sleep isn't as solid as wakefulness is. When you're awake, you pretty much stay awake until you fall asleep, unless you're very sleepy. Unless your sleep drive is so high, you cannot maintain wakefulness. But usually most people do throughout the day. As opposed to at night when you're asleep, people wake up frequently during the night. The typical adult will wake up many times during the night. They just don't remember because they're brief awakenings. So sleep isn't quite as stable as wake is, and you can imagine some potential evolutionary reasons why that would be selected for, that you wake up, look, no bear, go back to sleep, you know, because you're more vulnerable. Yeah, so you have the sleep-wake system where neurotransmitters like adenosine and histamine are also involved that maintain wakefulness until the sleep system is the hunger for sleep rises during the day, and then finally overtakes the wake system. It drops out, and then the sleep system sort of takes over for a while until it sort of dissipates and then the wake system can rise again. And so that's what's happening there. And from a circadian perspective, it's a little bit different, where on the circadian side, in terms of determining day versus night, it seems like pretty much every cell in the body has its own clocks that operate at roughly 24 hours. They're not precise and exact. It's a messy system, but they're at about 24 hours. And they need to sort of synchronize and interact with each other because your kidneys need to know when it's nighttime, and so does your liver, and so do your intestines, and so does your heart, and so do your lungs, and so does your skin. All these different systems need to know when it's nighttime so it can do its nighttime stuff, as opposed to knowing when it's daytime. And even though they have their own internal clocks, we do have one central clock in the brain that's used as kind of a master clock. It doesn't set the time for the whole day, but it does have a signal that permeates the body. And one of the ways it permeates the body is it sends information to the pineal gland in the brain that produces melatonin. And what melatonin has little to nothing to do with sleep. And a lot of people get this wrong. They think melatonin is a sleep hormone. It's not. Melatonin has no sedative properties at all. Melatonin is a nighttime signal. You produce it in the evening, you secrete it across the night, and then it drops right around the time your body's expecting your night to end. Whether you're awake or asleep, you're producing melatonin. For some people, like taking melatonin sends a nighttime signal at a time where it might tell the sleep system to like sort of get moving. But it's not a sleep signal, it's a nighttime signal. That's why if you give melatonin to a nocturnal animal, it wakes them up because to them, a nighttime signal is alerting. It's not sedative in any way. That's why it doesn't work for things like insomnia, because people with insomnia, most of the time, their body knows it's nighttime. They still can't sleep. That's why it doesn't do that. It can help with sleep, ironically, mostly for people who have more minor sleep problems. Like it can promote a sleep signal, but that's why it doesn't really overcome insomnia in that way. It's more of a clock signal. So if you want to take it, it tells your body it's nighttime. Well, if you're taking it at night, your body already knows it's nighttime, so it's probably not doing very much. Take it in the middle of the day, your body already knows it's not nighttime, so it's probably not going to do very much. But it's more about the transition times where you take it a little earlier in the evening, you get a nighttime signal a little earlier, wind down a little earlier, wake up a little earlier because you've shifted the whole thing over. Take melatonin first thing you wake up in the morning, your nighttime lasts a little longer, so you stay up a little bit later the next day. So that's why you have these different systems that are promoting sleep versus wake, and then all of that in the context of where in the 24 hours are you.
So could you give a few examples of like what's going on in the body and why we need these signals? Because I think people understand, like they know what an adrenaline feels like,
Yeah,
right? Like it changes your physiology in a certain way to act this
yeah,
way. And then sleeping is something totally different, and it's different than just resting, right?
right.
This-
Sleep is totally different than just resting. It's an Sleep is actually an active state in the body of various processes that are brought out during sleep. And it's because, evolution figured out a long time ago that it's much easier to change your car's oil while you're not still driving it. I mean,
Okay.
theoretically, it's possible, but it doesn't make any sense. It's like you can't refuel, you can refuel while you're still driving. I mean, airplanes do it in the military when they have long, whatever. It's not impossible to refuel while you're driving. And if we're all in a hurry all the time, why don't we have gas stations that drive up alongside us and refuel? Well, it's because it just doesn't make sense. The amount of expense and risk and all of that, it's just inefficient, and it's not a good idea. For the same reason as that, the body has all kinds of things that happen when you're disengaged from the environment. It's much easier to perform a number of different functions, especially in terms of recovery and repair and reorganization and things like that. While you're not engaging with the environment, you can sort of process what happens in the environment and prepare for the next engagement with the environment. So that's why you have things like cellular recovery and repair massively upscaled during the night while you're asleep. Because again, if you're trying to fix your roof, it's wait till the storm is over first. Then when it's calm, you do the repairs. You could do the repairs while you're still out in the rain, but if the rain is going to be ending predictably, just wait and then you fix it. And that's what the body does. There's a lot of these functions. And so, metabolism slows because you're not ingesting any food. So you got to last across the night. And so you have hormones that promote satiety and feeling full increasing over the night. So you don't get hungry all night, where it might be a few hours during the day, you start getting hungry again. But at night, you might be able to go 8, 10 hours without eating because you have these hormones that say, no, 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 don't worry about eating right now. Now's not the time for that. You have your immune system becoming upregulated during the night in certain ways and downregulated in other ways to be able to better heal, recover, respond to stresses in the environment, and to learn. Instead of just reacting to the environment, it looks like certain stages of sleep are really important in the immune system's learning process, not just the brain's learning process, but also the body's learning process as well. So things like blood pressure dipping during the night, that serves many important functions. For example, so because you're not moving around, you don't have to oxygenate those muscles so much. So you can have a reduction in heart effort and blood pressure. Well, what does that do? Well, if you're trying to do repair on the pipes, you want to lower the pressure on the fluid in the pipes so that they're not constantly bombarding the walls of the inside linings of all of your blood vessels all the time. By reducing that pressure, it creates an environment where it might be easier to recover and heal and repair, for example. There's all kinds of ways that these systems all interact, like cholesterol. Cholesterol gets created at night when you sleep. It seems predominantly that's what happens when it gets created in the liver. Well, why does the liver need to know when it's nighttime and you're probably sleeping to make cholesterol? Well, your immune system is then using cholesterol and from a cellular recovery and repair perspective. When does it want all of those raw materials? Well, at night when it's trying to do that. So that's why all these different systems in the body need to be kind of synchronized. But yeah, so that's the sort of thing that happens where pick a system, it's probably tied to sleep because sleep is so foundational to life on Earth. Most systems in the body evolved with a sleep wake cycle and used it. So evolution and biology is it doesn't waste things. So if it has an opportunity to have a period of disengagement, and if that makes certain things more efficient, they start aggregating there and they start collecting there, as opposed to stuff that's better to do when you're engaging with the environment, and those processes start collecting over there. So that's why pick a system. It's related to sleep somehow. Anytime there's any kind of regulation, there's probably some way that sleep has its hand in it for that reason.
And then those processes, are they like when you're eating, you can eat and then you eventually reach a point where you're done,
Yeah.
but just getting some food is better than not getting any food? Or is there some processes that like go through an actual like almost like you said building a process, like where it actually has to get to the end to be completed, or else like everything was kind of useless, like repairing your roof, where you have to
Yeah,
finish repairing or
that's
else
a
it's going
good
to leak.
question. It seems like most of it is the former, not the latter. If our sleep requirements were more rigid, we would have died out a long time ago. It
Okay.
looks like the things that are more rigid require like 4 to 5 hours. That's when like growth hormone is secreted. There's certain processes that really kind of, once you drop below 5 hours, there's just no way to even do them. After that, it's just about relative risk. It's just about inefficiencies. It's just about, well, you're not changing your oil when you should. You're sometimes riding on bad oil or whatever. Your engine isn't going to go up in flames unless you wait too long. But, your car, the life of your car is going to be shortened and it's going to become less efficient. As opposed to certain things like they just need you could do a repair, and if you're halfway done with the repair, it doesn't work. And so those sorts of things happen in the first few hours. Again, nature figured this out a long time ago.
Yeah.
When is the time you're most likely going to get not interrupted? You can delay sleep for survival. If you're running through that bear in the woods, you know, our ancestors who said, "Oh, bedtime," and then they go to lie down, they got eaten. The ones who said, "I don't care if it's bedtime, I'm going to keep going until it's safe, then it will be bedtime." They survive. So that's what we do. And we're not being chased by bears in woods anymore. We're being chased by like stress and deadlines and things. But even still, we delay bedtime until we're safe. And then we can fall asleep. And that is the time when we are least likely to ever be interrupted, because that's when most likely everyone else is asleep and we've found safety. So if the situation changes, it's probably not going to change right away. So that's the time that's most protected during the night by the body. But after that, it's just a matter of usually it's a matter of relative inefficiency, where you're still getting everything. It's just it may not quite be enough to be optimally functional. That's why
Okay.
it's all about relative risk. It's not about like if you go 3 nights in a row on 4 or 5 hours, you die. Like you don't. It's just you're not functioning well. You can recover, but the longer you go, the more inefficiency is being built on top of more inefficiency in terms of your own maintenance of your own body.
Okay, I like that. And is there sort of like a triage happening where it's like these are the critical things to get fixed?
Yeah,
And
yeah, your body. So that's why when people look at like some of their sleep tracker data, it's like, well, I only got this much deep sleep during the night or whatever. I don't care about that pretty much at all, because worrying about how much deep sleep you're getting is like worrying about your gas exchange in your lungs, where it's like, are my lungs exchanging enough oxygen? And it's similar. If you have a patient who comes in and says, "I don't think my lungs are exchanging enough oxygen." I looked at a thing and it says that looks low. I'm like, okay, is there anything wrong with your lungs? Any reason why they're not functioning properly? Lung disease, smoking, anything? No? Okay. Anything wrong with the air? Is it like polluted or something? Is the air fine? Yep, the air's fine. Do you feel okay? Like, yeah, I feel fine. Yeah, you're fine. Well, but this number doesn't look like it should be. It's like, well, your body's doing its job. Let it do its thing. Maybe the number is wrong, or maybe your body's doing it in a different way. And it's similar where, this number doesn't look right. Well, is there anything medically wrong with your sleep that's preventing you from getting good sleep? Do you have pain? Do you have undiagnosed sleep apnea or another sleep disorder or an autoimmune issue or something medical that's preventing your body from getting that sleep? No? Okay. Well, what about the environment? Are you sleeping next to a snoring spouse? Do you live on a busy street or trying to sleep with the light on? Like what's at the wrong time of day? Like what's going on in the environment? The environment fine? Environment's fine. You're in good health. You're giving yourself enough opportunity to sleep. Don't worry about your numbers. Your body's doing it. It's sort of like worrying about your metabolism. Like you can't make yourself sleepy. You can't change your sleep stages. You can't change, you can't make yourself metabolize faster. I mean, theoretically, there might be some stuff to nudge the system, but your body's going to do what it's going to do as long as you get out of the way. And it's more about looking to see what if there's anything in the way. But if not, let it do its thing.
but also a lot of people get messed up in different ways, right? There's lots of
Yeah.
people who have
Yeah.
issues
And,
sleeping.
and, and but
So
most of the issues are that there are barriers that we put in our own way. I mean, it's like
Okay.
when someone comes in and says, I'm having trouble sleeping, it's like saying I'm having trouble breathing. And the reason people have trouble breathing isn't just because they suck at breathing and I'm just never
Hmm.
been good at it my whole life. Like we were built to be able to do it. Why aren't you breathing? Is there something wrong? What's preventing your body from doing the thing it was naturally built to be able to do? Let's figure out what that is and fix
Okay.
that.
Okay. So when people complain about being sleepy, not getting good sleep, is that an issue where they're not getting enough of that deep sleep, or that's some of that extra stuff that just like is
It could
becoming
be any
inefficient?
combination thereof.
Okay.
I would
Yeah.
say if the first thing I would say is look at the different dimensions of sleep health and see how many of them you're hitting on. So the first one that you would look at is duration. Are you getting enough? I mean, you can have optimal nutrition, except if you're only eating 800 calories a day, I don't care what you're eating, it's not going to be enough. And so your body's not going to be getting what it needs, no matter what your macros and your proportions are. So, like, look at your duration. Are you getting your 7 hours ish? And that's 7 hours by your memory, not by a watch or a wearable. A wearable device will usually tell you 30 to 60 minutes less than what you remember. It's the what you if I asked you on average, how much sleep do you get? That's the number that should be 7 hours. If your watch says 6 or 6.5, I don't really care as much. It's more about, did it feel like 7? That's what matters. Because that's what predicts the outcomes on all of the research studies. It's not about the stuff on the watch is important too, but the 7 hours comes from self-reported data, not from wearable data, which will be less. So okay, so you're getting about 7 hours, 6.5. Is that okay? Man, maybe that's fine. But is it dangerous? Probably not until you get maybe past. Everyone's a little different, but for most people, 6 hours elevates risk sometimes and it does on average. 5 hours almost always elevates risk.
Hmm.
Less than that, it's usually a massive increase in the amount of risk you have. But people are different. So, but anyway, so there's duration. Then what you have is another dimension would be regularity, where how much of a moving target is your sleep window? Because remember, your body's trying to do all of these things when you're asleep, and it's trying to predict when that's going to
Hmm.
occur so that they can synchronize with each other. And then it's like, then your liver's like, oh, wait, we're sleeping now? I thought we were supposed to be awake now. Wait, we're sleeping now? Okay, hold on, let me do this. And then, oh, wait, we're awake now. Okay, we're awake now. And then so the body gets disorganized and dysregulated when sleep becomes a moving target. So it can move around a little bit. I mean, and the body doesn't know what a weekend is. So a lot of times that irregularity is just weekend weekday variability. But
Hmm.
still, it's a moving target. And so the more regularity, independent of anything else, irregularity itself predicts risk
Hmm.
because the body's trying to synchronize and organize, and it's constantly the rules keep changing. Another one is timing, where your body wants to sleep during your biological night to align with your circadian rhythm. A lot of times people aren't doing that. Um, One of the most common are young adults and teenagers being forced to wake up at 6 o'clock or 6:30 or 7 o'clock in the morning to go to school. To an 18-year-old, 6 a.m. could be like 3 a.m. to a 40-year-old. Imagine having to wake up at 3 or 4 in the morning every day to go to work. That's what teenagers are doing all the time. They're sleeping outside of their biological night. They have to wake up during the night and go to sleep too early. That's during their biological day because their clocks are shifted, for example. Shift workers is the obvious one, but a lot of people don't think about how just what some people would call a regular schedule, other people's call misaligned. So there's the alignment and the timing as a dimension. Another dimension is sleep continuity, or you could also call it sleep efficiency, where this is of the time you're in bed, how much of that time is actually spent asleep? Are you taking a long time to fall asleep? Are you waking up a lot of times during the night? Or are you up for a lot of time during the night? Are you lingering in bed in the morning? So your sleep is very shallow. Even not maybe not biologically, maybe the sleep you're getting is deep, but there's not a lot of it there. It's like, it's like you're either buttering bread and there's not enough butter to spread along the bread, or like you've got like little chunks of butter and then there's patches and then it gets all broken up and that's not good either, and that can lead to poor outcomes. So you've got duration, regularity, timing, continuity or efficiency. Another one is just sleep quality, where there's a lot about sleep we just don't have the technology yet to measure. And that's the how did you sleep? Was it restful or not restful? You can have be sleeping for 7 hours, you fall asleep right away, sleep, and then wake up in the morning, and it's always at night and it's at a regular schedule, but you're like, ugh, it just doesn't feel refreshing. Something might be going on that's keeping it artificially shallow. That's where you could look at sleep stages. You can look at like heart rate distribution across the night, or is there a sign that something's going on under the hood, like especially chronic pain or sleep apnea, that's causing that shallow sleep? So that irrespective of everything else, maybe the sleep maybe you're eating enough calories at the right time of day, having regular meals, but you're eating junk food. And so, like,
Mm.
that's the problem. And then the last dimension that I would look at is daytime sleepiness. Not necessarily tiredness and fatigue. People confuse them. You can be tired but still stay awake. And you could be sleepy and falling asleep and feel alert, but then nod off and
Mm.
not even know it. It's the
Yeah.
nodding off, it's the inability to maintain consciousness that is a sign that something is up with your sleep, because it's sort of like you can be hungry during the day, but if you can't keep yourself from eating, what's up with your appetite? If you're snacking
Okay.
all day and you can't stop, if you can't stop putting food in your mouth, what's up with your appetite? Something's up. And just like with sleepiness, you could be tired, that might be okay. But if you're sleepy, if you're having, if you can't, if when you sit, you fall asleep, if you can't make it through a TV show, if you can't sit in as a passenger in a car, if you can't sit through a meeting or a class, you're sleepy. That's the difference between tiredness and sleepiness. Sleepiness is a sign that something is up with your sleep wake regular. Your sleep drive is really high. Remember, we talked about sleep wake, that it's punctuating that wake drive where it doesn't belong. Why is it so high? Why is that sleep drive so high? Was it not able to get satisfied at night? Did you wait too long? What's going on? So sorry for the really long answer to your question, but you're like, okay, how do I know what's going on with my sleep? How do I think about it? Just think, duration, regularity, timing, continuity, quality, and daytime function. Where is it that there's a problem? Maybe you're okay on four of those, but you're missing one of them. It's like, okay, well, that's where I need to focus.
So I know there's a lot of people who are obsessed with performance and things like that, and they want to
Yeah.
maximize all those things, right? I was just wondering, I'm sure you can compensate for lack of one with another one, right?
Well, it's the difference of, so the question of how much do I need is often, I think, misunderstood, especially by researchers versus normal people. When people say, how much sleep do I need? That can mean all kinds of things. When a researcher says how much sleep or what kind of sleep you need, they're saying, what is the amount of sleep required for optimal functioning? But people don't always need optimal functioning, first of all. So, like, a lot of times people are saying, well, how much sleep do I need to, like, not get dementia or not get heart disease or not gain weight or not get diabetes or be able to think clearly or not have memory issues or not have fall risks and things? That might be different from optimal. I mean, you have a lot of people who are slightly impaired all the time and they're fine. Like, they live their life. Like, I mean, it's sort of, you have people who say, like, oh, I get by on this much. Well, it doesn't mean you're not impaired. It
Yeah.
just means you're probably not optimal, but you're probably okay. So it's sort of like, you don't have to have a perfect diet to not have a metabolic disorder. Like, so it's a different, what's your question? So part of it is, what's the question? If your question is, you know, sleep for just general health and functioning and survival, sleep doesn't have to be perfect to be perfectly fine. If it did, we would have died out a long time ago. But if you're talking about, okay, but how do I take what's good and just squeeze every ounce of goodness out of it? How do I just how do like athletes, so they're trying to think of, or people who are in high performance jobs in general. They want to be optimally functional, whether it's mentally, physically, or both. First of all, it's recognizing it's not about a number. That's like saying, how many grams of protein do I need to be optimal? well, is that number going to be identical every day? Is that, and it doesn't matter where that protein comes from and like what time of day you're like, so there's a lot of variables. There's no easy answers, but that's a good thing because you don't require easy answers. Your body's actually quite flexible. Like if you're getting in the ballpark, unless you're noticing issues, your body's handling it. It's like the gas exchange thing. It's like the metabolism thing. It's like your immune system. Unless you're getting sick, like how do I make my immune system better? Well, do you catch colds a lot? Do you get sick a lot? No, not really. It's like, do you get like maybe a couple times a year? Yeah, that's all I get. Your immune system's fine. Like, don't worry about your immune system. It's not a problem. There's like taking an immune booster is probably not going to do much for you because your immune system's working just fine. You're going to get diminishing returns. And the other thing to recognize is the effort you're putting in may actually backfire more than not putting in effort, because especially around sleep, where when people start exerting effort around sleep, it actually causes sleep to be worse because effort adds energy into the system. And if you're trying to sleep and you're worried about it, that adds energy in instead of pulls energy out. And sometimes, having imperfect sleep impairs your performance less than having slightly better sleep, but stressing out about it all the time.
I found some facts about athletes.
Yeah,
So yeah, so I was just curious about that. So like Michael Jordan was famous for sleeping like 5 to 6 hours a night, and then
yeah,
LeBron is famous for sleeping like a lot more than that, like
yeah.
8 or 9 hours. And I was just wondering, it's
So
like, so there's
first
no
of all,
rules or
I don't know. A lot of people who say they sleep less at night get more sleep than they think they do.
okay.
They may be napping during the day. Some people who are famously short sleepers are prolific nappers, but I don't know. I don't know what some people do. And some people, maybe he was slightly impaired. Maybe he wasn't. Maybe he was a natural short sleeper. Who knows?
Hmm.
Maybe he could have been better. Who knows? Is it possible to be high functioning and also not get the amount of sleep that is probably optimal for you? Yes. But when you think about it that way, it makes a little more sense. So if I were him 20, 30 years ago, and if he came to me and said, okay, this is what I'm doing, and I'm doing great. Do I need more? I would say, well, you don't need more to be great, clearly. But would you be better? I don't know. Let's do an experiment. There was that very famous study in the Stanford men's basketball team by Sherry Ma that she took an already great team, got them to sleep more, and their free throw percent went up by 9%. Their 3-point percent went up by 9%. Their sprints got faster. Like, they got better. They were already great. They were already on the Stanford men's basketball team, but they got better. So it just goes to show that it's not black and white. It's not like I'm bad versus I'm good. It's maybe you're great and maybe you're resilient and maybe you could be better or maybe you don't need more. And this is where the individual differences come in, and like I don't know what's right for you, but if you want to be better and you're doing it's like I drink coffee every day and I'm not sleepy. Do I need coffee or not? It's like, I don't know. Stop drinking coffee, let it go through the withdrawal, let it work its way through your system. Then after a week or two, tell me how you feel. Then I'll tell you if you really needed the coffee, because there's no way for me to know otherwise.
But it seems like, at least from that study you just said, that
Yeah.
probably people could do better. Most
Yeah.
people could do better. Yeah.
Yeah. If you're great, so there was a pro team I worked with once, and the phrase what they kept saying is we had a lot of guys who went from good to great. They were already good. They were
Mhm.
already professional athletes. They were already great,
Yeah.
but like they got better.
Just from
And
sleeping
sometimes
better.
just a little bit better makes the difference. It's that 1 second, it's that one split decision because that's the other thing. It's not just physical performance and alertness. It's also creativity, information processing, decision making, all that kind of thing.
Tie in what you're talking about teens and that they like to sleep in later. And I want to talk
Yeah.
about some of these differences that people have in circadian rhythm, and just in terms of personality, in terms of
Yeah.
productivity, because like we have rock concerts at night and we have
Right.
marathons in the morning, right?
Right.
So I
Right.
just want like,
Well,
is there,
and we have professional athletes competing at night, which is why, so like when you're traveling, it's always easier to travel west because it adds time into the day. Remember how I said delaying bedtime is actually easy for the body. We're built to be able to do it. And so extending the day, because and our 24-hour cycles are actually usually slightly longer than 24 hours anyway. So extending the day is natural. Shortening the day is what's hard. So traveling west is easier. And anyone who's traveled time zones can tell you traveling west, at least just a couple few time zones. Like when you're traveling 7, 8, 9, 10 time zones, that's just it's totally different. But traveling a few time zones west, way easier than traveling a few time zones east. Unless you're a professional athlete competing in a night game. And then the West Coast teams beat the East Coast teams even with their home court advantage or home field advantage because if the game starts at 8 o'clock and it's going till like almost midnight East Coast time, the West Coast team is earlier. They're 3 hours earlier. They're closer to their actual peak. That's why they're performing better. They're getting tired less because they're not at their bedtime yet. So yeah, I mean, so like when these things happen is important. Why is it that swimmers are in the pool at 5 in the morning? It's not
Yeah.
because that's when people swim the best. That's just they need to be out of the pool before the team sports go in, and they need to be out before it opens to the public or whatever. It's not because of that's when performance is better. I mean, a lot of college football teams, they practice really early in the morning. Not because that's when the best time to practice football is. That's when you're going to have more injuries, if anything. But they need to do it because otherwise, after that, they go to class and then they have homework. So when else are they going to do it? And that frees up the rest of their day. So, there's also logistics involved, and they can still be great in doing that. Could they be better if we got a little more strategic about it? Sometimes we don't have a lot of control, but there's timing for all this stuff, especially younger people. Like getting a younger person up at 5 o'clock in the morning is just cruel. Like
I
getting
feel
a
that.
teenager, a 20-year-old up at 5 or 6 in the morning, that's just cruel. It's they're not going to be at their peak performance. You're going to set them up for all kinds of problems.
You had some good evolutionary explanations for things. Do you have one for that?
Well, so think about it this way. There's some really great studies that go into all kinds of different so into different cultures. As you mentioned before, sleep is very culture bound. It's very personal. Sleep is like food, where it's something we require to live, but how we go about it is very, very much dictated by where we come from and our culture and our socioeconomics and all these sorts of things. So there are these great studies that go into like hunter-gatherer societies in sub-Saharan Africa that don't have electricity. So what do they do? What was funny is there's some great insights that come out of this work to see like, because there's so much of our environment that changes how we sleep. It's like, what about that environment? How do people sleep in that environment? Well, they get about 6.5 to 7.5 hours. Sometimes they say they want more. The younger people stay up late. The older people get up early. Sometimes they'll take a rest in the afternoon. Sometimes they'll nap, but not always. And that's humans. And if you want an evolutionary explanation, one of the hypotheses is, younger people are really good at having children, but they're not as good at taking care of them. Who's really good at
Okay.
taking care of them? Their parents. What happens to younger people? They stay up late when their parents go to bed. That's when they get to do their younger people things. But then the
That's what I
older
was
people wake
thinking.
up early while the younger people are still sleeping to help take care of the kids. And so, but also you have through most of the 24 hours, you have somebody who's alert, whether it protects the tribe, whether it, scouts for danger. You have people who are naturally, even given the bell curve of who's more of a night owl or more of a morning person, you have pre-programmed certain age groups to be more morning people and more younger and more night people, so that the same person can cover the 24 hours at different stages in their life, for example. So, it seems humans are social animals. We're not meant to live alone. We're meant to live in groups. And when you put groups of humans of varying age groups, you have people alert all around the clock. Um, to do tasks, protect the village, tend the fire, whatever.
I feel like culturally now it's used as a way to segregate young
Yeah.
people. They stay up late to
Yeah, well, especially
especially the
since the old people make all the rules and decide what's normal. So they create a work day around their schedule. And then they make everybody feel bad for not being able to wake up so early. But you know, hopefully I feel like that's changing. I like this is why, you know, having high schools start so early, it's developmentally inappropriate. So a colleague of mine, Wendy Troxel, she does some of this work and she talks about school start times. And one of the things that she says, which I think is brilliant, is, you know, well, they say high schoolers start work early because it mimics sort of the work day and whatever, or at least the, you know, the older work day. Most people don't start work at 7 o'clock in the morning, that some high schools do. But you know, it's like it prepares them for the working world and getting up early and having a schedule. And they're like, she's like, that's dumb. It's developmentally inappropriate. It's like saying, you know, we shouldn't let preschoolers nap because by the time they get to high school, they're not going to be allowed to nap anymore. It's like, well, that's developmentally appropriate. So of course we're going to let them nap because we know what happens when we don't. Well, we know what happens
okay.
when we don't let high school kids sleep to a normal time. They fall asleep during the day. Their mental health is worse. They get ADHD diagnoses. They need stimulants to stay awake all day. They don't perform well, so they don't academically succeed, which sets them up for less academic success later in life. And they don't have the skills to be able to regulate because they never learn them because they're so tired. And so you set them up to fail. And some of them succeed nonetheless. I mean, I had calculus at 7:20 in the morning. That's why I went into psychology because I couldn't do calculus at 7:20 in the morning.
Okay.
But, you know, like that's the thing where I think if we get a little more conscientious about it, we realize some of these things we take for granted aren't there because they're better. They're there because they were convenient for a time and a level of technology where it made sense, but may not make sense anymore.
Got to find some teachers that are
Yes.
young at heart and
Yes.
on the same sleep schedule as the young people. Want to tie it to longevity as well?
Sure. Yeah, I mean, so the very first study that linked sleep to longevity was published in 1964. And what they showed was the people who were getting about 7 to 8 hours of sleep lived the longest. And then that pattern has been borne out in dozens of studies from around the world. Every continent but Antarctica that I know of has data showing that it doesn't matter what culture you're in, doesn't matter where you're from, but it seems like if you're able to get good sleep and have a healthy sleep pattern, you are more likely to not. It's not that people who don't sleep well will always die sooner. It's just it's all about relative risk. So there are plenty of people who have crappy sleep that live long. There's plenty of smokers who live to 100. You know, doesn't mean that smoking is good for you and smoking will help you live to 100. It just they did it despite the odds, not because of them. You know, but on average, it looks like, you know, the better your sleep, the more closely your sleep is aligned with what we would define as healthy sleep according to those different dimensions I talked about earlier, those people tend to live longer and be healthier. You know, they gain less weight, they get less high blood pressure, they get less diabetes, they get less dementia, they get, you know, they have fewer accidents and injuries and disabilities. They, you know, pick an outcome. They have less kidney disease. Like pick an outcome. I will show you the data that it seems to be that just because it's so foundational. And that's why it might lead to longevity because all the things that contribute to longevity are supported.
I like to end with just what do you think are the important topics that people in your field should be studying? What are important things for us to
I
know?
think I think what's really important is the concept of sleep health and circadian health and how these processes are just absolutely fundamental to how our biology works. I mean, all of these processes are probably related. And the more we understand all those connections, not only the more we can make impacts on health outcomes that we care about, but we can also figure out how to, you know, optimize what we have, improve our technology, improve our decision making, and at the end of the day, make better choices and make more informed choices so that, you know, we're not just struggling with this all the time. I mean, you meet anyone on the street, you tell them about sleep, and they start having a story, and everyone has a story.
Yeah.
And because it's universal. Sleep is something that it doesn't matter whether you live in a gated community in suburbia or in a castle or in a war zone. You still have to go to sleep tonight. Doesn't matter whether there are bombs going on outside your window or you're in the middle of a jungle. Like, you still have to go to sleep tonight. This is something that connects all of us and always has through all of history and always will. And, you know, our society tends to see sleep as an unproductive use of time. And that is where the problems come in. It's because we're trying to optimize our time usage, not realizing that it's actually a very productive use of time. And so then what ends up happening is we sacrifice something good for something less good, and we get a bad deal for it. And we realize things are slightly off, and we don't know why. And there's many reasons why things in this world aren't the way they are. But, if you're not sleeping well, they're all worse.
Okay.
And if we can, and the more we understand about not only just why it's important and how it's important, but how to make better choices to navigate the complex world we're in. And how do you get busy people who don't have time to sleep more to become more productive and efficient? These are the things that I think we need to understand a little bit better.
I was gonna go into animal stuff, but if you have a favorite animal that sleeps in a funny way, I'd love to hear about it.
So a lot of people may not realize that whales and dolphins sleep half their brain at a time. Sleep is so important that their brain switches off left and right while they're sleeping, because they got to keep moving. So half their brain has to sort of stay awake, and it just shows how important sleep is. Another favorite of mine is actually not an animal. It's a computer. There's a there you may not even you forget the data showing you might not even need a brain to sleep. You might not even need to be alive to need sleep. Where any sufficiently complex system might require sleep. And I don't mean rest, not like when you put your computer to sleep, it shuts off. What I mean is there's this great paper that came out a few years ago where what they took a deep learning AI model that had to discern and adapt to its environment. Think of as an example, when I talked to the author of the study, he used an example of like a self-driving car needs to learn how to navigate a three-dimensional world. You can't feed it the rules because there's an unlimited number of rules about the universe. You just it has to learn. It has to learn how to learn. And that system that they designed, when they added in a model that did what the brain does during sleep in terms of filtering out information and solidifying certain connections and filtering out other connections without engaging with the information, but by processing it in a very specific way, mirroring what's called the synaptic homeostasis hypothesis, where in terms of where information that's not deemed as important gets dropped, but information that is important is strengthened. When they were able to model the brain patterns of a sleeping person on the deep learning system, it dramatically improved its ability to learn, like off the charts. And it shows that sleep is all about adapting to a complex environment. It seems to be something that the reason why it was figured out a long time ago is it's shockingly effective at being able to navigate and adapt to changing it, which is why humans need it. But anyway, yeah,
Great.
that's some of my favorites.
Awesome. I really appreciate your time. This was
Thank
a
you
lot of
so
fun.
much.
You're a great speaker.